Hello, everyone! Today, we begin a fascinating chapter called Exploring Algebraic Identities. Have you ever noticed that mathematics is full of hidden patterns? Take 3 consecutive square numbers. If we add the first and the last, then subtract twice the middle number we get equals 2. Try it with other consecutive square numbers, and the result remains the same. Is it just a coincidence, or is there a mathematical reason behind it? The answer lies in algebraic identities, special equations that are true for all values of their variables. One of the most important identities is a plus b squared equals a squared plus 2ab plus b squared. But why is this true? Imagine a square of side length a plus b. Its area is a plus b squared. Now divide this large square into 4 parts, a square of area a squared, a square of area b squared, and 2 rectangles, each having area ab. Adding the areas of all 4 parts gives a squared plus ab plus b squared, which simplifies to a squared plus 2ab plus b squared. This gives us a visual proof of the identity. Similarly, a minus b squared equals a squared minus 2ab plus b squared can be understood by removing smaller regions from a larger square. Another powerful identity is a squared minus b squared equals a plus b times a minus b. How can mathematicians calculate 72 times 68 without performing the usual long multiplication? We can write it as 70 plus 2 times 70 minus 2. By applying the identity, it becomes 70 squared minus 2 squared, which equals 4900 minus 4, equals 4896. Instead of lengthy multiplication, a simple algebraic identity gives us the answer in just a few steps. We'll also encounter identities such as a plus b plus c squared equals a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. X plus a times x plus b equals x squared plus a plus bx plus ab, and ax plus b times cx plus d equals acx squared plus ad plus bcx plus bd. These identities help us expand expressions, factorize them, and even simplify rational algebraic expressions by identifying common factors. The chapter also introduces cube identities. A plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. A minus b cubed equals a cubed minus 3a squared b plus 3ab squared minus b cubed. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. We'll also discover the special identity. X cubed plus y cubed plus z cubed minus 3xyz equals x plus y plus z into x squared plus y squared plus z squared minus xy minus yz minus xz. Finally, identities help us compare expressions as well. Since a plus b squared equals a squared plus b squared plus 2ab, if a and b have the same sign, then a plus b squared is greater than a squared plus b squared. If they have opposite signs, then a plus b squared is less than a squared plus b squared. And if either a or b is 0, the 2 expressions are equal. By the end of this chapter, you'll see that algebraic identities are much more than formulas to memorize. They are powerful tools for discovering patterns, proving results, simplifying calculations, factorizing expressions, and understanding why mathematics works.